I would like to graph both of these inequalities. Now in order to do that, we first have to put them into this format called slope-intercept form. So we're going to graph these. Let's see what happens. So first thing I'm going to do is distribute the 3. 3 times x is 3x. 3 times negative 1 is negative 3. Then here I'm going to get y by itself, so I minus the 3 over. That's gone. Negative 3 and negative 3 is negative 6. So that right there is one of my new equations, which is really easy to graph in comparison to the previous. And for this one, I want to get also to the same format. So I'm going to minus the 2x over. These two do not combine, so I put that 2x, negative 2x first, just for notation purposes. This cancels. Don't lose that negative there. A lot of people lose that negative. You've still got the negative 4y over here. Now I divide by negative 4i, both sides, which basically means everything. That's going to cancel. That right there becomes a positive 1/2, and that right there becomes a negative 2. But if you notice, the sign flipped. If you ever divide by a negative in simplifying, the sign, inequality sign, will flip. So this is a greater than, used to be a less than. We are now going to graph these two. So in order to graph those, let's look at the graph down here. So here we go. We have the graph right here. It's a cool looking graph. Now, as we look at this graph, you see the two equations here. There's the orange one, and there's the blue one. So let's see how we graphed it. Let's start with the blue one. Negative 2, so we started at negative 2, and 1/2 is my slope, so I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. And then it says greater than, so that is a dashed or dotted line. So greater thans are dashed. And then it says greater than, so greater than means top. So if you put your finger right there on the graph, if I go up, oh, that's where I'm going to shade. So see how they're in blue? The blue is shaded for the blue graph. If you go to any dot, just go on the graph. Greater than means go up, and that's the side. Another way people say greater than is kind of like the top of a slide. Let's say that's a slide. Greater than is going to be if you're on top of the slide. Less than would be below the slide. Now a little thing here can help too. If you have a line that looks like this, greater than's on top, less than's on bottom. Greater than's on top, less than's on bottom. Now the reason for the dotted line is because it's just greater than and less than. See how this is a solid line? Greater than's on top, or greater than or equal to is on top, less than or equal to is on bottom. Greater than or equal to is on top, less than or equal to is on bottom. So those little helps. Remember, if it has an or equal to, it's a solid. If it doesn't have an or equal to, it's dotted. So you can see right here. See how the orange one here is a solid line? See how it's less than? So see how it's going uphill? So we know it less than, we know we're going to be shading this side, which you can kind of see here in orange I shaded. Let's talk about graphing it though. Negative 6, so we start at negative 6. Slope is 3, so we go up 1, 2, 3 over 1. 1, 2, 3 over 1, 1, 2, 3 over 1. Keep doing that. Make a solid line. And again, since it's less than, what I do is I take this and I go down a little bit. Take any point, go down, and that's where we're going to shade. Or you could think of it as under the slide. If this is a slide, you're under the slide. So we basically graph two separate inequalities. You graph this one, you graph this one. Now the solution is where they overlap. See right here where it kind of darkened it? All this area, all this space right here is the solution. Choose any point in there, and it will become true for both inequalities. So I chose a coordinate 3, 1. You could choose any coordinate in this double shaded region, and that would be a solution. So what we're going to do is we're going to verify that it is a solution. So let's check that 3, negative 3, 1. We're going to show that that actually is a solution. So I'll go over here. I take the coordinate 3, 1. So I put x is 3. So what we did is we plugged it into the original function. Let's show you that original function real quick. Pull it down. So here's the original function. As you can see, here's the function. And all I did is took x and I plugged it in for x. And I'm plugging y and I'm plugging in for y. See right here? That's 1 is y and 3 goes in for x of the original function here. Let's see what happens. 3 minus 1 is 2. Over here 1 plus 3 is 4. Then we got 3 times 2 is 6. And then we look at this. Okay, is 4 less than or equal to 6? Well, that's true. Good. It should be. Because any point in that double shaded region should be true for both. So we're half checked. We also got to check 3, 1 into this function too. So as you can tell, there's x, there's y. So can you tell I put 3 into x, 1 into y, x, y, x, y. And then so 2 times 3 is 6, and 4 times 1 is 4. Don't forget the negatives. You can think of that as negative 4 times 1 if you want. But basically, so we got 6 and a negative 4. 8 just stays over here. And 6 minus 4 is 2, and 8 stays. And is 2 less than 8? Well, yes, it's true. So good. It's true for both. So any point, again, going back, any point that is in the shaded region, so any point we choose here would end up being true for both. If I chose a point here in just the blue, it would only be true for that equation. If I chose a point in the orange, it would only be true for that equation. If I choose a point down here, it'd be true in neither. It'd be false in both. So, but what we're looking for is where they overlap. That's the solution, and we're verifying a point in that area.